Well. So in number 11, you have to find the area between... Luna, do that down the back of the room. You'll distract me standing there. Do down the back. Thank you, thank you, thank you. Oh, yeah. Oh, you'll distract me standing there. So find the area between the x-axis and the lines K and L. So what happens? It's frozen. Yes, Windows, yes, yes. Disappointing, yes. No, it's not Windows 8. There we go. Hey, look, it's just a low-powered netbook. That's all it is, okay? There's no advanced graphics card in it or anything. Right, so you have two lines. X, Y, and the first line is going up. So the first line would look something like this. This is line L. Now the second line, line K, what type of line is that? X equals minus 1. What type of line is that? Yeah, but what's special about it? It's a vertical line. So maybe I'll just draw that one again here, but put it a bit more. So that's L, and then this one would be K here. It's just a vertical line. So the area we're looking for is this one here, because it's the area between the lines and the x-axis. So it's a little triangle. We do know this point. What's this point here? Salma, is that you? We don't know this point here. But how do we find this point? Well, we're told what the L is. The L is y equals 5x plus 10. So how can I find this point here? Y equals 0. And so what will x equal? Minus 2. So now what you have to do is integrate from minus 2 to minus 1, 5x plus 10 dx. Okay, so what's the antiderivative here? It would be 5x squared over 2 plus 10x. Minus 1 and minus 2. If I put the minus 1 in, I'll get 5 over 2 minus 10. And if I put the minus 2 in, I'll get 2 squared is 4, 4 over 2 is 2, so I'll get a 10 there, minus 20, I hope. So if I put this all together, is that right? No? Yes? So putting that all together, minus 10 is minus 20, but then I get minus 20, so that'll cancel. So actually I'll just be left with 5 over 2. 2.5 units squared. And that's 11 then. So I'll do 17 next. 93. Okay, so I'm going to do 17 next. Just have a read of 17 for a moment. Question? Blind action, sorry, yeah. Right, so have a look at that next one there. Say that again, Mohammed?
Units.
Yeah, units squared, yeah. I didn't specify the units. You know, could be meters squared, centimeters squared, whatever. Yeah, very good. So I think I'll use derive to draw a nice graph here. Okay, so this is your book, isn't it, Siobhan? So I'd like you to read the two quadratics out to me. Wait, hang on. For derive to start. I don't remember any sound when I start derive. But yes, Amjad, you're right. One will be a U shape and the other will be a hill shape. Come on. There we go. Taking longer today. Must be tired. Yeah, needs holiday, yes. Right, what's the first one? X squared, 12x, minus. Yeah. Next one?
Minus x squared, minus 12x,
Plus 1. Okay, so let's draw these two. So the plotting those. So let me. I'll have to zoom out. Okay, and then the second one here. So the area I'm looking for is this one here. Okay. So I'm looking for this area that's trapped between the two curves. Now, do you remember from the last class there was a little trick to finding that area? Do you remember what it is? Yeah, what do you have to do? No, not this, no. Subtract, but which one? Subtract which one? Which minus which? The upper one minus the lower one. So here, which one is the upper one? The red one, which is the minus x squared. Andy, please. Andy, please, listen. It's fine. Andy. So the red one minus the blue one. So that's line 2 minus line 1. So you subtract the two of them. And let's clean it up a little bit. So after you subtract them, you'll end up with this quadratic. Yep, you can be writing that down. Then what do? You integrate. But we don't know what the limits are, do we? So how can we find the limits? We have to solve them. So you have two quadratics. How can we solve them? Yeah, well, they're both equal to y, aren't they? Y equals this one, and then y equals this one. So what technique do we use? Just equate them. So you can say here, the first equation equals the second equation. Now what type of equation will that be when you simplify it? Quadratic. The x squareds don't cancel here. So simplify basic. Oh well, hang on. I'll solve it. Huh? Well, this is minus x squared. It'll go to the left, become 2x squared. Solve expression. Solve. So there are the two limits. Minus 15 to 3. So I'll just put that in full screen there. Yes, it is the same answer. So now we just integrate this here. And the limits are, what was the lower limit? Minus 15 up to 3. See, minus 15 to 3 of that will give you this answer. Yes?
Should we always subtract the minus one with the positive one?
No, it's always the upper one minus the lower one. The one on top minus the one on bottom.
No, you do know that. It's going to be the upper one.
Well, if it's two quadratics, the only way you can make a shape in between is if one is like this and the other one's like this. Because if it was the other way around, I mean, it's the only way you can kind of make a type of a circle if they were like that, you know. So yeah, in that case, for two quadratics, it would always be the negative one minus the positive one. Yes?
Was that what you used today?
Yes. Okay, write that down, please. Everything is there. The only thing that's missing is the working calculation steps in between. So look, this is the first equation, this is the second equation, this is the subtraction, and this is the solution. Then we equate them to find the limit, and we integrate, and then we're done.
But then when we say the upper minus the lower,
Yes. I did.
okay, so it's the lower minus the upper.
No, this one here is the upper. That one is the lower. The upper was this one.
Okay.
Yep. Okay, did you write that down? Yes. Yes.
Oh, this one.
Yes.
How about minus 4 simplify? But the answer is...
Well, you know what you can do. Yeah, because actually all of these questions I asked for area, and area should never be negative. So you forgot to put the minus in front, because this one here went underneath the x-axis.
How did you know?
How did I know? You need to draw this. For homework, if you want to, yeah, that's fine. Because usually in the exam, they would ask you to draw this first as a question, and then to find the area.
So if I want to do all of this one,
You had a whole lesson on drawing quadratics. You
just
can,
do this one.
Yep.
If MC is x plus,
Yeah.
how do it?
yes. And then you find the roots. You know, we had a whole lesson on drawing quadratics, and a whole lesson on drawing cubics, and a whole lesson on drawing linears. We've done plenty of drawing. If your answers are coming out as negative, that means you forgot to put the minus in front of your integration because it's underneath the x-axis. That is common. In the exam, if that happens, just change the answer to a positive. It's fine to do that. You can put the minus in later at the end. Okay.
Minus 15 what? X equals minus...
Oh, that symbol there means or. My x is minus 15 or x is 3. What?
So how
I don't know what you're saying.
do we know x is minus 3?
Mohammed,
Are you?
Mohammed,
Yeah.
you asking me that? Oh, I see you picked a bad day to be sick. You shouldn't have been sick for the last class. You'll have to just watch the video. Sorry, man. Okay, now we can start the revision. So let me stop the recording for this one.